Okay, so now let's look at what an actual limit is. So remember, we have from the board previous that a limit is not what a function is, but what it is going to. We will actually see this phrase in a little bit more use in one of the examples we're going to look at. So we say if a left-handed limit, remember that's as x approaches some value from the left, and we use that minus sign to indicate from the left because the left is less than. And the right-handed limit, again, we use a plus for that symbol because plus means greater than. If it's from the right, it's greater than that value. So if the left-hand limit and the right-hand limit are equal, then we say the limit as x approaches a. Notice we do not have a plus or a minus right here. We're not saying from the left, we're not saying from the right, we're saying from all sides. The limit as x approaches a is equal to those two limits. So for example, in the last one we looked at, we had the left-handed limit and the right-handed limit were both equal to that y value L. So if that's the case, if the left-handed limit and the right-handed limit are equal to L, then the limit as x approaches a, again, neither from the left or from the right, but from all sides, is also equal to that value L. So let's look at that example. We just did this right here. We did this one in the last slide, or in the last video, but if you don't remember it, take a moment to pause the video right now and try to fill out all of these little things in these two examples. And I guess I can erase that error right here because I don't have it down there. But anyway, take a minute, pause the video, try to fill these out, and then play the video again. Okay, so if you've gone through and tried to solve these, you should see that as we approach, in this example number 1, as we approach a from the right, the limit is L. As we approach a from the left, the limit is L. Sorry, I mixed those up. The first one's to the left and the second to the right. So if both the right and the left-handed limits are exactly the same, that means the overall limit as x approaches a is also equal to L. Okay, so let's look at example number 2. In example number 2, as we approach f of x from the left, it is again approaching that y value L. So that limit is going to be L. As we approach it from the right, it is again approaching that y value L. So if we wanted to look at the limit of this function as x approaches a, since the left and the right-handed limits are equal, this is just going to be the same as that. So the limit as x approaches a will be L in that case. Now, here's the trick. If I asked you, what would f of a be if we plugged in the value x equals a into the function, what would we get? Well, we see an open circle right here and a closed circle. Remember what open and closed circles means. A closed circle means that's what the function actually is at that point, x equals a. So if we wanted to fill out f of a, that would be equal to p. Now this example right here illustrates this saying right here, a limit is not what a function is, but what it is going to. So here, in this case, the function is equal to p at x equals a, but p is not what the function is going to. Trace with your fingers across the function. It is not going to that value p, it is going to that value L. So in this case, the limit as x approaches a would be L, but the function evaluated at a would be equal to p.